The syllabus asks you to understand the effect of uniformly distributed load without involving calculations. That in itself is fairly difficult. We just had a look at shear force diagrams and how with a point load on a beam, you basically end up with, let's just draw the shear force diagram. Shear force diagram is horizontal loads. Might look like that. I haven't given it numbers intentionally. I've just picked a random set of forces. The shear force diagram follows the loads. The bending moment diagram is basically a triangle. It would look something like that according to the maths that I've got drawn. That is bending moment, that is shear force. Notice this goes through 2 points on there's the maximum, there's the minimum bending moment. If it's got 3, then you've got a third point of inflection as well. So, that is straight out point loads. A uniformly distributed load, let's just pick 1, 2, and a, this is the symbol for a uniformly distributed load, or this is basically the weight of a beam. In engineering studies, we assume the bridge weighs 0. Or if it does have a weight, we say assume it acts through the centre. We all know that that's not the real world. The bridge has a massive weight. That is a uniformly distributed load. Now you need to understand this without calculations. Let me just rub out the second one. I'm just going to leave that there. How does it look? I have got a massive weight up. That is the shear force diagram. Like that. Force up, gradual drops down, force comes back up. The syllabus specifically mentions 0 calculations. What I want you to understand, memorise this, because the syllabus says use calculations. Then, that one's sloped straight lines, this one is now sloped straight lines. And bending moment is force times distance. If I was to add up that area under that and keep on going, I would end up with this beautiful upside down parabola. Looks like that. So it's a curve. So flat, sloped, standard action of point loads. Point load. And this is uniformly distributed loads, sloped and parabola. That is what you need to know. The effect of uniformly distributed loads on the shear force and bending moment diagrams without calculations. Point loads, you need to know the calculations. Make sense?